Hi there, I'm Jason, and you're watching
Jason!
Let's try to apply the Pythagorean theorem in order to solve the side lengths of the missing part in a right triangle. Now, example, we have here, given the right triangle ABC with right angle at C, find the missing part when A equals 4, B equals 3, and C, or the hypotenuse, is unknown. Now, according to the Pythagorean theorem, A squared plus B squared equals C squared. Now, since the values of A and B are already given, so we can already substitute these values. So let's substitute 4 to A and 3 to B. So that's why we have 4 squared plus 3 squared equals C squared. Now, 4 squared equals 16 and 3 squared equals 9. So that's why 16 plus 9 equals C squared, which is copy C squared. Now, 16 plus 9 here, that's 25. So 25 equals, bring down or just copy C squared. So in order to find C, we need to get the square root of both sides. So we need to get the square root of 25 and C squared. So the square root of 25 is 5, right? And the square root of C squared is C. So that's how we get 5. So we have now the missing value of the hypotenuse in the right triangle ABC. Okay, let's try another example for you to understand it better. So, example 2, given the right triangle SON with the right angle at O, let's find N, since S equals 8 and O equals 10. So, the missing part here is N, which is one of the legs of this right triangle SON. Now, according to the Pythagorean theorem, A squared plus B squared equals C squared, or we have here N squared plus S squared equals O squared. N here is now the variable for one of the legs as well as S. So N and S here are the legs of the right triangle. Now, since the one of the legs is missing and the hypotenuse is given, so we just have to, just like what we did in our first example, we just have to substitute the given values. Now, let's substitute 10 to O and 8 to S. So we have here N squared plus 8 squared, since 8 is the value of S. So equals 10 squared, since 10 is the value of O. So that becomes N squared plus 8 squared, that is 64, and equals 10 squared, that is 100. So we will subtract 64 to both sides. So N squared plus 64 minus 64 equals 100 minus 64 to eliminate 64 here. So it's a way of simplifying the equation. Now, N squared, this side becomes N squared. And this side becomes 100 minus 64, that is 36. So let's find the square root of both sides to get N. So N equals square root of 36. Therefore, N equals 6. So using the Pythagorean theorem class, we are now able to find the missing part of this right triangle SON.